Good morning, students. Today we will be discussing about research and documentation. In that, we will be looking at data types and processing. Data is a raw material for any information. Data can be defined as a set of values of qualitative or quantitative variables. It is a collection of facts such as numbers, words, measurements, observations, or even just description of things. Once data have been collected and processed, they are ready to be organized into information. The collection and organization of data are an integral and critical part of the research process. Data are intended to represent facts, and without proper preservation of the context of collection and interpretation may become meaningless. The collection of data and its analysis assists researchers with discovering answers to their research questions and hypotheses. In some cases, it even predicts future outcomes. This is why data is an integral part of research. The results of research and its methods are directly dependent on collected data and its analysis. It is extremely important to maintain integrity, accuracy, and completeness while collecting data. Accurately collecting data ensures correct answering of research, repeatable and validated experiments, no wastage of resources, benefits other researchers, no harm to human subjects and animals, and public policy decisions are not compromised. Data is measured, collected and reported and analyzed, whereupon it can be visualized using graphs, images or other analysis tools. Data as a general concept refers to the fact that some existing information or knowledge is represented or coded in some form suitable for better usage or processing. Data processing commonly occurs by stages, and the processed data from one stage may be considered the raw data of the next stage. Field data is raw data that is collected in an uncontrolled environment. Experimental data is data that is generated within the context of a scientific investigation by observation and recording. Data can be classified basically into two types, quantitative and qualitative. Qualitative data. Qualitative data is a categorical measurement expressed not in terms of numbers but rather by means of a natural language description. In statistics, it is often used interchangeably with categorical data. Example: favorite color is blue, tall wall, heavy body, etc. Though there are categories, they may be structured. When there is not a natural ordering of categories, those categories are nominal categories. Examples might be gender, race, religion or sport. Nominal data is the one in which numbers are only used as labels. For example, if one wants to categorize adolescent girls and adolescent boys, nominal scale of 1 for girls and 2 for boys could be given. But 1 and 2 in this case do not represent any order or distance. They are simply used as labels. A nominal data shows the categories of a variable as a numeric value. Nominally, scale variables cannot be used to perform many statistical computations such as mean and standard deviation, because such statistics do not have any meaning when used with nominal scale variables. However, nominal scale variables can be used to do cross tabulations. The chi-square test can be performed on a cross tabulation of nominal scale data. When the categories may be ordered, these are called ordinal variables. Categorical variables that judge size like small, medium, large, etc. are ordinal variables. Attitudes like strongly disagree, disagree, neutral, agree, strongly agree are also ordinal variables. However, one may not know which value is the best or worst of these issues. Ordinal data have a meaningful order to them. One can assign order to the variable or respondent. For example, assigning rank 1 which is higher than rank 2 and 2 is higher than 3, etc. Instead of rank 1, 2, 3, use any other number which preserves the same order. This is because it is not known sure what the distance between 1 and 2 is or what the distance between 2 and 3 is. Statistics median various percentiles such as the quartile and the rank correlation can be used on ordinal data. In addition to this, frequency tables and cross tabulations on ordinal data can also be used. Arithmetic mean should not be calculated on the ordinal scale variables. Quantitative data is a numerical measurement expressed not by means of a natural language description but rather in terms of numbers. However, not all numbers are continuous and measurable. For example, the social security number is a number but not something that one can add or subtract. These data have meaning as a measurement, such as a person's height, weight, IQ or blood pressure. Or they are a count, such as the number of stock shares a person owns, how many teeth a dog has, or how many pages you can read of your favorite book before you fall asleep. Quantitative data always are associated with a scale measure. Quantitative data may also be discrete and continuous. Discrete data can only take certain values like whole numbers. Continuous data can take any value within a range. In simple manner, discrete data is counted, continuous data is measured. Discrete data. Discrete data represent items that can be counted. They take on possible values that can be listed out. The list of possible values may be fixed, also called finite, or it may go from 0, 1, 2 on to infinity, making it countably infinite. For example, the number of heads in 10 coin flips takes on values from 0 through 10, finite case, but the number of flips needed to get 10 heads takes on values from 10, the fastest scenario, on up to infinity, if you never get to the 10th heads. Its possible values are listed as 10, 11, 12, 13 and so on. Continuous data. Continuous data represent measurements. Their possible values cannot be counted and can only be described using intervals on the real number line. For example, the exact amount of gas purchased at the pump for cars with 20-gallon tanks would be continuous data from 0 gallons to 20 gallons, represented by the interval 0, 20. Inclusive. You might pump 8.40 gallons or 8.41 or 8.414863 gallons or any possible number from 0 to 20. In this way, continuous data can be thought of being uncountable infinite. For ease of record keeping, statisticians usually pick some point in the number to round off. Qualitative data deals with descriptions, whereas quantitative data deals with numbers. Qualitative data can be observed but not measured. Quantitative data can be measured. Qualitative data requires colors, textures, smells, taste, appearance, beauty, etc. Whereas quantitative data looks at length, height, area, volume, weight, speed, time, temperature, humidity, sound levels, cost, members, ages, etc. Qualitative data defines quality. Quantitative data defines quantity. Example of qualitative data. An example of oil painting. If we look at qualitative data, we look at blue, green color, gold frame, smells old and musty, texture shows brush strokes of oil paint, peaceful scene of the country, masterful brush strokes. However, for the same example of oil painting, in quantitative data, we look at the picture is 10 by 14, with frame 14 by 18, weighs 8.5 pounds, surface area of painting is 140 square inches, the cost is $300. Example 2, food. In qualitative data, we look at robust aroma, frothy appearance, strong taste, burgundy cup. However, for the same food, when we look at quantitative data, we look at 12 ounces of latte, serving temperature 150 Fahrenheit, serving cup 7 inches in height, cost is $4.95. Example 3, classroom. In qualitative data, we look at friendly demeanors, civic-minded environmentalists, positive school spirit. However, for the same example of classroom, in quantitative data, we look at 672 students, 394 girls, 278 boys, 68% on honor roll, 150 students accelerated in mathematics. Quantitative data focuses on numbers, numeric values like who, what, where, when, and match with outcomes about knowledge and comprehensive. Allows for measurement of variables, uses statistical data for analysis, may be generalized to greater population with larger samples and easily replicated. Qualitative focuses on text, narrative from respondents like why, how, match with outcomes about application, analysis, synthesis, evaluate, and seeks to explain and understand. Quantitative and qualitative data provide different outcomes and are often used together to get a full picture of a population. For example, if data are collected on annual income, quantitative, occupation data, qualitative, could also be gathered to get more detail on the average annual income for each type of occupation. Quantitative and qualitative data can be gathered from the same data unit depending on whether the variable of interest is numerical or categorical. For example, to understand quantitative and qualitative data, we need to have a data unit, a numerical variable which defines quantitative data, a categorical variable which defines qualitative data. Example 1. A person. How many children do you have? How much do you earn? And how many hours do you work will be under numeric variable. The quantitative data will be 4 children, $60,000 per annum, and he works for 38 hours per week. In categorical variable, the questions will be in which country were your children born, what is your occupation, and do you work full-time or part-time. To understand qualitative data, the answers will be following. His children were born in Australia, he is a photographer, and he works full-time. Example 2. A house. Numeric variable. How many square meters is the house? The quantitative data is 200 square meters. The categorical variable will be in which city or town is the house located. The answer for the qualitative data would be Brisbane. Example 3. A business. Numeric variable will be how many workers are currently employed. The quantitative data will be 264 employees. The categorical variable will be what is the industry of the business. The answer for qualitative data would be retail. Example 4. A farm. How many milk cows are located on the farm will be the numeric variable. The quantitative data will be 36 cows. The categorical variable will be what is the main activity of the farm. The qualitative data answer would be dairy. The above data has been acquired from Australian Bureau of Statistics. Frequency counts. The number of times an observation occurs, frequency, for a data item which is variable can be shown for both quantitative and qualitative data. The graphs below arrange the quantitative and qualitative data to show the frequency distribution of the data. The following are the graphs shown for quantitative data and qualitative data. For quantitative data, for frequency count, of hours worked per week for a population of 20 is shown. On x-axis is hours worked and on y-axis is the frequency. For qualitative data for a population of 20, the frequency count of occupation. On x-axis is occupation and on y-axis is frequency. And absolute frequencies can be calculated on quantitative and qualitative data. Relative frequencies can also be produced, such as percentages, proportions, rates and ratios. For example, the graphs above show 4 people, 20% worked less than 30 hours per week and 6 people, 30% of them are teachers. Descriptive statistics. Statistics that describe or summarize can be produced for quantitative data and to a lesser extent for qualitative data. As quantitative data are always numeric, they can be ordered, added together, and the frequency of an observation can be counted. Therefore, all descriptive statistics can be calculated using quantitative data. As qualitative data represent individual, mutually exclusive categories, the descriptive statistics that can be calculated are limited, as many of these techniques require numeric values which can be logically ordered from lowest to highest and which express a count. Mode can be calculated as it is the most frequency observed value. Median, measures of shape, measures of spread such as the range and the interquartile range require an ordered data set with a logical low end value and high end value. Variance and standard deviation require the mean to be calculated, which is not appropriate for categorical variables as they have no numerical value. Inferential statistics. By making inferences about quantitative data from a sample, estimates or projections for the total population can be produced. Quantitative data can be used to inform broader understandings of a population or to consider how that population may change or progress into the future. For example, a simple income projection for an employee in 2015 may be inferred from the rate of change for data collected in 2000, 2005 and 2010. As shown in the graph below, data collected over time indicates a 5% increase every 5 years. Therefore, if the rate of increase continues to follow the same pattern, it can be projected that the annual income for that employee in 2015 will be $46,305, which is the 2010 wage of $44,100, increased by an additional 5%. For inferential statistics, we can represent the chart as following. You can see that the year is mentioned on x-axis and income in dollars is mentioned in y-axis. The annual income chart is thus represented like this. In the year 2000, the annual income was $40,000. In the year 2005, the annual income was $42,000. In the year 2010, the annual income was $44,100. In the year 2015, the annual income was $46,305. Qualitative data are not compatible with inferential statistics as all techniques are based on numeric values. Editing is the process of checking and adjusting the data for omissions, legibility, and consistency. Editing may be differentiated from coding, which is the assignment of numerical scales or classifying symbols to previously edited data. The purpose of editing is to ensure the completeness, consistency, and readability of the data to be transferred to data storage. The editor's task is to check for errors and omissions on the questionnaires or other data collection forms. The editor may have to reconstruct some data. For instance, a respondent may indicate weekly income rather than monthly income, as requested on the questionnaire. The editor must convert the information to monthly data without adding any extraneous information. The editor should bring to light all hidden values and extract all possible information from a questionnaire while adding nothing extraneous. In large projects, field supervisors are often responsible for conducting preliminary field edits. The purpose of field editing the same day as the interview is to catch technical omissions such as a blank page, check legibility of the handwriting, and clarify responses that are logically or conceptually inconsistent. In-house editing. Although almost simultaneous editing in the field is highly desirable, in many situations, particularly with mail questionnaires, early reviewing of the data is not possible. In-house editing rigorously investigates the results of data collection. Editing for consistency. Editing requires checking for logically consistent responses. The in-house editor must determine if the answers given by a respondent to one question are consistent with those given to other. The in-house editor must determine if the answers given by a respondent to one question are consistent with those given to other related questions. Many surveys utilize filter questions or skip questions that direct the sequence of questions depending upon respondent's answer. In some cases, the respondent will have answered a sequence of questions that should not have been asked. The editor should adjust these questions, usually to no answer or inapplicable, so that the responses will be consistent. Editing for completeness. In some cases, the respondent may have answered only the second portion of a two-part questions. An in-house editor may have to adjust the answers to the following questions for completeness. Example, does your organization have more than one internet website? Yes, no. If a respondent checked neither yes nor no but indicated 3 internet websites, the editor may check the yes to ensure that this answer is not missing from the questionnaire. Coding. Coding involves assigning numbers or other symbols to answers so the responses can be grouped into limited number of classes or categories. The classifying of data into limited categories sacrifices some data detail but is necessary for efficient analysis. Nevertheless, it is recommended that try to keep the data in raw form so far it is possible. When the data have been entered into the computer, one can always ask the computer to group and regroup the categories. In case the data have been entered in the computer in group, from it will not be possible to disaggregate it. Although codes are generally considered to be numerical symbols, they are more broadly defined as the rules for interpreting, classifying, and recording data. Codes allow data to be processed in a computer. Researchers organize data into fields, records, and files. A field is a collection of characters. A character is a single number, letter of the alphabet, or special symbol, such as the question mark, that represent a single type of data. A record is collection of related fields. A file is a collection of related records. Files, records, and fields are stored on magnetic tapes, floppy disks, or hard drives. Code construction. When the question has a fixed alternative, closed-ended format, the number of categories requiring codes is determined during the questionnaire design stage. The codes 8 and 9 are conventionally given to don't know and no answer respectively. However, many computer program fields recognize a blank field or a certain character symbol recognized such as a period as indicating a missing value. There are two basic rules for code construction. First, the coding categories should be exhaustive. With a categorical variable such as sex, making categories exhaustive is not a problem. However, when the response represents a small number of subjects or when the response might be categorized in a class not typically found, there may be a problem. Second, the coding categories should also be mutually exclusive and independent. This means that there should be no overlap between the categories to ensure that a subject or response can be placed in only one category. This frequently requires that an other code category be included so that the categories are all inclusive and mutually exclusive. For example, managerial span of control might be coded like 1, 2, 3, 4 and 5 or more. The 5 or more category ensures everyone a place in a category. When a questionnaire is highly structured, pre-coding of the categories typically occurs before the data are collected. In many cases, such as when researchers are using open-ended response questions, a framework for classifying responses to questions cannot be established before data collection. This situation requires some careful thought concerning the determination of categories after editing process has been completed. This is called post-coding or simply coding. The purpose of coding open-ended response questions is to reduce the large number of individual responses to a few general categories of answers that can be assigned numerical scores. Code construction in these situations necessarily must reflect the judgment of the researcher. A major objective in code building process is to accurately transfer the meaning from written answers to numeric code. Okay students, this is all about data types and processing. Do you have any questions?
Hello ma'am, I have a doubt. Can you please explain the difference between qualitative and quantitative data?
The difference between qualitative data and quantitative data is qualitative data deals with descriptions, whereas quantitative data deals with numbers. Qualitative data can be observed but not measured, whereas quantitative data can be measured. Colors, textures, smells, taste, appearance, beauty, etc. define qualitative data, whereas length, height, area, volume, weight, speed, time, temperature, humidity, sound levels, cost, members, ages, etc. define quantitative data. In short, qualitative data deals with quality and quantitative data deals with quantity. Thank you.